Hi everyone, welcome to Manohar Chemistry YouTube channel. Today I am going to explain chemical kinetics part 4. So in this session I am going to explain chemical kinetics first order reaction and its integral equation, half-life time and some competitive aspects regarding chemical kinetics first order reaction. So to understand first order, I am taking one hypothetical chemical equation. Here A gives product, one hypothetical chemical equation. So that is A gives product. So according to this rate law, so rate is directly proportional to concentration of reactants. Here reactant is A, so that's why rate is directly proportional to concentration of A. So we know that rate is nothing but change in concentration of the reactant with respect to time. So instead of rate I am taking change in concentration of A with respect to time, dA by dt is equal to, so K integral constant K1, so into concentration of A, right? So then after, so separation of variables, so A term should come nearby dA. So change in concentration of A upon dA is equal to K1 into dt. So now take integration on both sides. Then integration of dA upon A is equal to integration upon K1 into dt. So here integration of dA by A is equal to K1 is constant, so that K1 into integration of dt. So integration of dA means ln A is equal to integration of dt is nothing but K1 into T plus I naught. So I naught, so ln A is equal to K1T into I naught. To know the value of I naught, I am taking T is equal to 0. When T is equal to 0, whatever the concentration present, that we call it as what? Initial concentration. Then A will become A naught. Just to substitute these two values in this equation 1. So when in place of A you have to substitute A naught, ln A naught is equal to K1 into 0. Why? Because we are taking time 0, so plus I naught is there, right? So here I naught value, ln A naught is equal to, that is I naught value. So substitute this I naught value in equation 1. Then ln A minus is equal to K1 into T minus of ln A naught. Take this ln A naught left hand side, then ln A naught minus ln A is equal to K1 into T, right? So this is in the form of log A minus log B. So ln A minus ln B is equal to ln A by B. So then ln A naught upon A equal to K1 into T. So that K1 into K1 is equal to 1 by T into ln A upon A naught upon A. So this is integral rate equation. So to change ln to logarithm, log, we need to multiply with 2.303. So that K1 is equal to 2.303 by T log A naught by A. So this is final integral equation of first order reaction. So here K1 stands for, K1 is equal to first order rate constant, T stands for time, A naught stands for initial rate concentration, and A stands for final concentration. So now expression of chemical kinetics first order in one more way. Now we are going to take limits. So means initial concentration and final concentration. Now we are going to take integral equation in between two limits. So why two limits here you see? So I am taking again one hypothetical equation. A gives product here. So at T is equal to 0 means reaction not yet started. Its initial concentration is Ga. So product concentration is 0. After T is equal to T second, some X part is going to, from A, X portion is going to form product, then the remaining quantity here a minus x, so this one is what, x. So now we are going to take integration limits initial concentration and final concentration. So according to rate law, first order equation, rate is directly proportional to concentration of A. So to remove direct proportionality, rate is equal to K1 into integration, K1 into concentration of A. So rate is nothing but minus dA by dt, change in concentration of A with respect to T is equal to K1. So then after K1 into concentration of A. So then again separation of variables, so dA by A will come, so is equal to K1 into dt will come. So again take integration on both sides, take integration on both sides, then integration of dA by A is equal to K1 into integration of dt. What I told you just now, take two limits. So we are going to integrate this one in between two limits, that is initial concentration and final concentration. So time intervals are t is equal to 0 to t is equal to t I am taking. So 0 to t. Time intervals are 0 to t, concentration is initial concentration and final concentration. Now dA by A is nothing but ln A. So integration of 1 by A is nothing but ln A. So A and A minus x. This one we call lower limit, this one we call upper limit. So K1 into integration of dt is nothing but t. So limit is 0 to t, right? So just you substitute upper limit, then after lower limit. So ln of A minus x, so minus, so ln of A. So upper limit substituted, then after lower limit. So here also K1 into, so upper limit is t and lower limit is 0. So when we are taking integration in two intervals, then no need to substitute, no need to take integral constant. So then after minus ln A minus x here, then after, so minus ln A. So is equal to K1 into t will come. Just you multiply with this negative, then minus ln A minus x, so plus minus into minus plus, so then after ln A is equal to K1 into t. So this is in the form of ln A minus x is equal to K1 into t. Again this is in the form of ln A minus ln B. So ln A minus ln B is equal to ln A by B. So ln A by A minus x will come is equal to K1 into t. So I am going to change this equation like this. So K1 is equal to 1 by t into ln A by A minus x will come, right? So to convert this one into ln to logarithm, then we need to multiply with 2.303. So then K1 is equal to 2.303 by t logarithm of A by A minus x. So again here K1 is rate constant, and t is time. So A is initial concentration, and A minus x is final concentration. Different types of expressions will be there for rate. So instead of A minus x, they will take C naught and C also. So that I am going to explain one more way. So integral equation of first order chemical kinetics, K1 is equal to 2.303 by T log C naught by C. Here C naught is nothing but initial concentration, C is nothing but final concentration. Then after one more expression, K1 is equal to 2.303 by T log of A by A minus x. This is also one more expression. So again K1 is equal to K1 is equal to 1 by T into ln A by A minus x. This is also okay. So K1 is equal to 1 by T ln C naught by C will come, right? So I am taking this last equation. So by multiplying T, here T is dividing, then you take this side. So K1 into T is equal to ln C naught by C will come. So here base E will be there. So when you are taking C naught upon C is equal to e to the power of kt will come. C naught upon C is equal to e to the power of kt. Here I am taking like this. So C by C naught is equal to what? 1 by e to the power of kt will come. So here I am taking reciprocal. So here C by C naught is equal to 1 by e to the power of kt. Here I am taking reciprocal of this one. So that's why it will become reciprocal. So then C by C naught is equal to e to the power of minus kt will come. So C is equal to C naught into e to the power of kt will come. C is equal to C naught into e to the power of minus kt will come. So this we call it as what? Exponential rate. This we call exponential rate. Why? Because we are expressing here concentration in e to the power of something. So that's why we call it as exponential concentration. Concentration in exponential terms. So if you are taking like this, then k1 is equal to, you take this integral equation now. So k1 is equal to 1 by t into ln a by a minus x I am taking. So again k1 t is equal to ln a upon a by x, a minus x. So here again a upon a minus x is equal to e to the power of k1 into t will come, right? So again I am taking reciprocal a minus x by a, which is equal to e to the power of minus kt will come. So here for this I am taking a by a minus x by a, we can write like this, is equal to e to the power of minus kt. When same base is there for this, both elements same base is there, so that we can take like this, same denominator is there, so that a by a is nothing but 1, so x by a so is equal to e to the power of minus k1 into t. So here 1 minus x by a is equal to e to the power of minus k1 t. So x by a is equal to 1 minus e to the power of minus k1 into t. So x is equal to a into 1 minus e to the power of minus k1 into t. So here x is nothing but what? Concentration of product, this one. Concentration of product value we can calculate like this. Concentration of reactant will be calculated like this. Concentration of reactants and concentration of product. Here this is also concentration of the reactant. This one is nothing but concentration of the product. Half-life of first order reaction. Half-life of first order. So half-life is nothing but the time required to complete half of the initial concentration is called half-life of a reaction. If 100% reactant concentration is there, so at what time 100% will become 50%? That time we call it as half-life time of a reaction. So half-life time will be calculated like this. So according to integral rate equation of first order, k1 is equal to 2.303 by t log a by a minus x. So here x value is a half of initial concentration. So just you substitute x value in that equation, then k1 is equal to 2.303 by t will become t half. Why? Because we are discussing half-life of a reaction, so that log a by a minus, so instead of x what I have to take a by 2, so that k1 is equal to 2.303 upon t half. So log 2a by 2a minus a will come here. So k1 is equal to 2.303 by t half. So log 2a by a will come, a get cancelled. So k1 is equal to 2.303 by t half into log 2. So t half you take this side, then t half is equal to 2.303. So log 2 value 0.3010. So by k, so t half is equal to 2.303 into 0.3010 is nothing but 0.693 by k. So this is half-life of a first order reaction. So taking one more equation, so k is equal to 1 by t into ln a by a minus x, then k is equal to 1 by t into ln 2a by a will come here, a get cancelled. So then k1 is equal to 1 by t into ln 2 will come. When you are taking ln equation, so then this is the half-life of a reaction, t is equal to t half. Why? Because we are calculating half-life time here. So when we are substituting instead of x a by 2, then only we have to take t half. So this is in case of ln, this is in case of what? The log equation. So half-life of a reaction, first order reaction, t half is equal to 0.693 by k. So in this half-life you see initial concentration is not there. So means half-life of a first order reaction does not depend on initial concentration of a reactants. So here based on half-life there is a chance to ask different types of questions in competitive exams. So I will explain later. So again one more equation, t x percentage, to complete x percentage, so that is 1 by k into log of 100 by 100 minus x. This formula we have to use. To complete 75%, to complete 35%, how much time required, they will ask like this. And ty percentage is equal to 1 by k into logarithm of 100 by 100 minus y. So initial percentage is 100, you have to take tx percentage. Then after tx percentage upon ty percentage, tx percentage upon ty percentage is equal to, so you take 1 by k get cancelled. So log of 100 upon 100 minus x, so upon log 100 by 100 minus y. So these are the some of the important formulas regarding first order reaction. Derivation of 1 by nth part. Derivation of 1 by nth part. So to complete 1 by nth part, how much time is required? So you take first integral equation of first order reaction, k1 is equal to 1 by t into log of a by a minus x is there. So the time we need, so t 1 by n. So time required to complete 1 by nth part of initial concentration. So 1 by k1 into log of a by a minus, instead of x, so we need to take a by n. So since here x is equal to what? 1 by n. So a by n, a by n. So t nth part, time required for completion of nth part is equal to logarithm of a by an minus a upon n will come. So t nth to 1 by nth part, so 1 by k1 is equal to log of n a by a is common here, n minus 1, a get cancelled. So t 1 by nth part is equal to 1 by k1 into logarithm of n by n minus 1. So this is one of the important equation regarding competitive exam. So t 1 by nth part is equal to 1 by k1 into log of n by n minus 1. N is nothing but to completion of nth part. So based on Half-Life, there is a chance to ask different types of questions. To explain that, I prepared one chart, I will explain. So that chart, based on this chart, we can solve maximum questions of T of half-life of a reaction. So this chart is no need to memorize. One simple trick is there to write this chart. I will explain that chart also. So first, if 100% is the reactant concentration is 100%, for example, concentration of reactants is 100%. In that, how much percentage is completed after 3 T halves, after 4 n halves, how much percentage is remaining? That thing can be calculated by like this: percentage remaining after n T halves. So that is nothing but 100 by 2 to the power of n we need to take. So then after, so remaining concentration, this is in percentage, this is in concentration, remaining concentration after n T halves is equal to a by 2 to the power of n. So for example, so initial concentration is 16 moles is there, for example, initial concentration is 16 mole. So after 3 half-life times, how much quantity will be remaining in a reaction? So that thing can be calculated like this. So initial concentration is how much? 16 by how many half-lives are completed? 3 half-lives are completed, so 2 to the power of 3. So 16 by 8 will come, 2 to the power of 3 is nothing but 8, 8 1 ja, 8 2 ja. So that 2 moles will be left in a reaction after completion of 3 half-lives. By using this reaction, we can calculate this type of reactions. Based on this table, how can we solve different types of questions you see? So number of T halves here, concentration remaining. So after 1 T half, how much concentration of reactants will be remaining? So after 1 T half, how much completed from this, or how much product formation takes place. This is one of the chart. So here you see first T half, concentration will be, from initial concentration 50% will be completed and 50% formation will take place. In second T half, in this 50%, again 50% is nothing but 25. So that here 50% formation will take place. So from this 25% is going to form product. So then 50 plus 25 is how much? 75. 50 plus 25 is how much? 75, right? So again from this 25, again one more T half. In third T half, 25 by 2 is nothing but 12.25. Just you add this 12.25 to this 75, then you will get what? 87.5. Again you take 12.25 is nothing but 6.25. So you add this 6.25 to this one, again you will get what? 93.75. So again from 6.25 in this half means 3.125. It is a fifth half-life. After 5 half-life times, if concentration is 100%, initial concentration is 100%, then in that 3.125 will be remaining and 96.875 will be completed. 96.875 will be completed at 5th T half. So in 5th T half, remaining quantity is 3.125 and completed quantity is 96.875. So based on this chart, this is very easy to remember. So then based on this table, how can we solve answers like this? So here you see, for example, to complete T75%, how much T halves will be required? So here you see T75, to complete T75, how many T halves are there here? 1 and 2. So that's why in between T75 and T half relation is 2 into T half. 2 into T half. So to complete T, for example, T96.85 relation you need. T96.85 relation. So T96.875, to complete this much percentage. So how many T halves are required? 1, 2, 3, 4, 5. At 5th T half it's a 96.875. So 96.875 is nothing but what? 5 into T halves will come. To complete 99.9%, to complete T99.9%, so 10 into T half will come. 10 into T half. So how to, based on this relations, how there is a chance to ask questions, you see. For example, in one reaction, so T half is 10 seconds. T half is 10 seconds. Then how much time required? Then how much time required? How much time required to complete 99.9% of a reactant concentration? 99.9%. So we have a relation T99.9 and T half. So how many times it will be? 10 times. So that's why T99.9 is equal to 10 into T half, right? So here T half value is 10. So that's why 10 into 10 is 100. So to complete 99.9%, it required what? 100 seconds. So based on this table, you can find out T half and some other percentage, X percentage relation. It will be very helpful to you and it is very easy to remember. No need to by heart this. Based on simple trick, you can find out this table.